That is a big question we should have in our mind. So what is a data model? That is a big question we should have in our mind, as I told you a few seconds ago. So data model is what actually? A data model is nothing which is just only the conceptual tool for describing the data and its functionalities and the relationship between the data semantic and consistency constraint. So that is a point you have to understand. So this is our slide which describes the introductory part about the data model. So as a name given by the data model means the modeling of the data. So modeling of the data can be done by the various graphical representation. So that's why we have the data model. So what is its definition part? So data model is nothing which is just collection of the conceptual tools for describing the data relationship and data semantic and consistency constraint. So data models define how the logical structure of the database is modeled. It means how two entities, how two different attributes can communicate to each other. That is a more important point. It is just like example, if I take a simple example, a faculty and student can be a related part. So faculty and student are the both and two entities. So faculty and student are the both real-time entities. It means faculty and student, if they are both are the entities, and both also required to contain some properties, and those properties are known as the attribute. So what is the property or what is the attribute of a student? Student roll number, student name, semester, class number, and year in which he or she is reading or studying. And next we can say the subject code, different things we can put it over. And faculty can have the faculty ID, faculty name, and which department he or she was joined or working, and number of the classes and course in which he or she is taking. So that is the thing which is identified by the attributes or properties of the such entity. So data models, I'm speaking once again, define how the logical structure of the database is modeled. So data models are fundamental entities is to introduce the abstraction in the database management system, and data models define how data is connected to each other. So it is just like the story which is inspired by the flowchart. So while studying the data structure subject, what we have to do? Before writing anything, we will design the algorithm, we will write an algorithm. So while writing the algorithm, where we have to start? First, we will draw the conceptual diagram, and that diagram is known as our flowchart. So after understanding the flowchart, you will write the algorithm for the specific problem or solution as a solution unit. So this is what? This is a graphical representation of the solution of the problem. So that's why we can say over here, data model is what actually? That is a logical structure which defines how our data will be connected. So that is the thing you have to understand. So previously we will use the flat data model, and that is known as a simple text file, we can say. So the relationship will not be stand there. So what we have in the flat data model, we have a different files, and each and every file has own structure, but the files are not connected to each other, and they are not making the relationship between the other files as well. So that's why we can say that was not successful. So as we have studied in our first and second class, the flat database or flat files are not suitable. That's why we have some drawback in the flat files, and that supported the flat data model. So the drawbacks we have seen. So overcome to this problem, we have database management system, and this database management system can be depicted by the various data models. And here we have to study the data model. So that is the point from which we have to start the data model. Let me move to the next slide, and which describe the different things. So I have already written various material over here. So we discussed this thing with the other slot as well. So same thing, I'm just speaking over here and just not removing any content over here, but I'm speaking the same thing to all the people, then you can easily understand. So in the concise way, a database model basically defines and shows the logical structure of the data. That is a, and that includes the relationship and constant that determine. Constant means the conditions or the some constant rules we can impose to our model to define the things properly. Age cannot be inserted by the alphabetical letters. That is the point. So it should be on the numerical only. So that is a constraint we can say. And we are in the our data model, we have a different kind of constraint. So we will see step by step. Whenever you have any problems, you can ask me. So that is the point we have to understand. So relational database we have seen. If you remember the relational database, we have seen that is a logical structure. And what is the logical structure of the relational database? Of course, in the tabular form, and tabular form will be represented by the two way. One is the rows and columns. So rows will be identified the records, and column is identified by the attributes. So relational database, I am speaking once again, will be the represented by the tabular manner. That is the logical structure of the our data model. So we will see each and everything step by step, and that part we have seen. So I am discussing over here. Right? After this point, we have to move to the next slide and just see that is the relational model. So what is the relational model? A relational model is just nothing which describe the information in form of the tabular manner as we have seen. So as I told you, if you remember my previous classes, in the previous classes, I think the fourth or fifth class, I discussed this point. The relational model will be applicable in the relational database. It means the database which is used by the relational model, then we have a relational database, and the relational model will be represented by our information or data in form of the tabular manner. So that's why sometimes this model is known as the tabular model. This thing is not written expertly. This thing is hidden inside our concept. So naming convention can be asked in the examination in different ways. So please keep in mind the thing properly. So that's why we can say that the most popular data model in the database management system, we have a relational model. It is more efficient and specific model to show the data properly, and it is better than the others. And this model is basically based on the first order predictive logic. So I will tell you all the things what is mean by the first order predictive logic, and that part we will see in the relational algebra. But here I am just talking about the only relational model only. So we will see this part only. So what is actually relational model properly? So relational model uses a collection of the tables, both data and relationship among those data. And each table have multiple column, and each column has a unique name. That is a point you have to understand. Student name, attributes or column name cannot be multiple time. Student name is I am writing one time column, so that would be only one time. If I am writing multiple times, there will be no sense. That is the point. So student roll number, field or attribute or column I'm taking multiple times, there will be sense? No sense. So that's why it is written over here. We can take the multiple column, many columns we can take, but each column must have a unique name. That is the point. Okay, so this is just introductory part about the first model, that is a relational model. I'm speaking once again, what are the models? Models, we have the relational model, network model, hierarchical model, and ER model. So before telling to each and every model, we are starting our concept what we mean by the data model. So we have sent just introductory part, that is the logical structure of the database management system, and in which we have seen the first introductory part of our model, that is the relational model. So from this point, we have this example. So before telling to this example to all the people, just can anyone tell me right now, the everything I'm discussing over here, is it clear to all? Or
Yes,
anything
sir.
you need to ask, so please. Any problems so far? Any problems so far?
No, sir.
Okay, good. So this is the diagram in the tabular manner. Is it visible to all?
Yes, sir.
Okay. So this is the important diagram which describes the entire concept of the relation model. So I'm once again highlighting all the things properly, so you can see there is our relation or file which is a name over here, the student. So you can see at the bottom side, I am just highlighting table or relation. We can say this is the name of the table. We can say this is a table. We can say this is a table. We can say, or we can say this is a file. We can say this is a file. So this is the naming convention only based on the different way we can speak. So we can say it is a table, we can say it is a relation, we can it is a file. So depend on the our concept, we will see only the naming convention, nothing else. SID is the student's roll number. SID is the student roll number. Student name we have, student age we have, student class we have, and student section we have. This is what actually you can observe over here. All these things are known by the columns. I'm speaking once again. All these are known by the columns, and all these are also known as the attributes. Student ID, student name, student age, student class, student section are known as the columns, or these are also known as the attributes. In this case, we have one more thing, that is a record. Suppose I'm talking about this record 1102. Student name is Maria, and her age is 15, and class is 9, and section she belongs to the A. So entire thing which is highlighting by me over here by this row is known as the records. So this is a record of the student whose name is Maria, and roll number is 1102, and age is 15 years old, and class is 9, and she belongs to the section A. So this is what this is known as a row, and this is also known as the our record, and this is also known as the tuple in relation algebra. And what is mean by the tuple and what is mean by the relation algebra, I will tell you later on. But we have to keep in mind, this is only just naming convention. So this is known as our rows, and this is known as our tuple, and this is known as our record. After understanding this point, you people are required to understand the thing properly. The value I have marked by me over here in the arrow symbol, 8 and Maria and Maya, Bob's, Newton. So all these are the data values of the respectively column. So I'm talking about the student name, and whose name is Newton. So Newton is what actually, this is the data value or data element of our student name column. So the point we can understand, a student can ask me the question, sir, what is the definition of the record? Record is nothing. Record is a collection of the data values or data points which are associated with the columns or attributes, and nothing else. And this is the various terms which are required to understand by the relation model or our tabular model, we can say. So this is what, this is nothing, this is the simple information of our relation model example. So now we have this point, because our data will be represented by the rows and column in the relational model. Now, is it clear to all? Yes, tell me right now, student, is it clear to all the terms, or any terms you have? So please, you can ask. Although we have discussed this point previously, so I'm just scratching once again all these things. So now, is it clear to all right now? Anyone who need to ask any problem over here? Any topics, any concept, any terms you need to ask once again, then you can ask. Is it clear to all?
Yes, sir.
Yes, sir.
Okay, good. And do not forget this. Yes, do not forget any terms over here. Yes, tell me right now.
Sir, the rows, like the first row, do we count it in row, or is it just attributes?
No. This is not a, basically this is not a row. So you are looking for, this is a row. This is not a row. This is our heading, which is comprising by the name of the columns. So student ID, student name, student age, student class, student section, which is written over here. That is only our headings. So if you remember the practical part yesterday, what we have seen, we have created a table. So in the table we have defined the various attributes. So attributes we are defining, or we are first attribute was the roll number, second was the name, another word was the date of birth, and third one was the fee, something like this one. So these are the only the columns, and this is not belong to the rows. Rows will be represented by the data values. I'm speaking once again. What is the definition of records or rows? A rows is a collection of the data and data values and which are associated with the our respectively columns. So student ID I'm putting over here 1101. So that is what 1101 is a data value and that will be associated with the student ID. That was a simple point. So first row will be started from the 1101, next 1102, third one is 1103, and respectively we have the 100, 1104 and 1105. So in this our data, this in this our records or list of the records or this table, we have total 5 records only. That is the point. Now clear?
Okay, sir. Yes, sir.
So I am speaking once again to all the students. Please do not forget the various terms we have seen over here. Each and every terms are required to understand the advanced concept in the coming classes. After understanding this point, we have to see this is the same example and this is the same example I have explained with the other slots. So this is the point. Now let us discuss this example. Relational database comprising of the two tables. That is important point. That is important point. You people are required to open your eyes now and just listen the concept properly. Once you have missed the concept, definitely you can't say you will not be able to learn the thing properly. Before that, let me inform you all, just let me give you some idea. I will show the demonstration with the practical, of course. What is the key attributes? That is a big question we should have in our mind. What is the key attributes? Can anyone tell me right now what is the key attributes?
Account
Attribute
number.
we have. The account number we have, but what is the key attribute? What is definition? What you are thinking?
Sir, it may be a unique ID or something associated with that data value.
Yeah, super. You are on the right track and good. Any other student who want to just clarify this term properly?
Sir, on the basis of which others can be distinguished from that entity.
Okay, good. Okay, any other student just wanted to clarify the more answer properly? Okay, so I'm just writing here what is mean by the key attributes. See, this part you will see in the detailed study
Sir, a
of
key
the.
attribute should be unique.
Okay, that is a great point. I'm accepting. Okay,
It should be
what is?
basically the primary key.
Yeah, okay, primary key. Definitely, thank you. And what is the key actually? So now, what is the key actually? In the database management system, we have heard this term that is the key. What is the key? So the what is the key actually? That is a point we have to understand properly. Without understanding this point, you are not able to understand the next slide. That is the my point. So key
So,
attribute. Yes, tell me.
like key is a unique entity in the database database which is not repeated, like it has no duplicate data, and that key is important because it holds the information of that record, because
Hmm.
it has the if there is a student database, then the student name, suppose our roll number, that 20 BAI 10001 or any 20 BAI 1 any number, that is our that is the key that holds our information, like our name, our which branch we are, and that is the
We can import to the other database using key.
Okay, good, good. I'm accepting all the points right now. And no.
So a key
Yes.
is that entity which points to a particular value which is unique in that attribute, and it can be distinguished from other data values.
Okay, okay. So I got a great answer from all the people. Thank you all. So those students who don't not understanding the what is mean by the key, so I'm speaking in general whether the thing will be clear to all. Key is what basically what key is basically defines the uniqueness in the our record, and that key is basically defines the I can write over here define defines uniqueness in the record. That is the point. Uniqueness in the record. So if I'm saying if my record will be unique, so what is the attribute I must take as a key attribute? So if I'm talking about the student roll number, so that would be the unique, because in any university or in any college or anywhere, a student name can be duplicacy, but student roll number cannot be at any cost. That is the point. So the example we can take student roll number would be the key attribute which define the uniqueness in the record. The product ID, if I'm having a product ID, so product ID would be the uniqueness. Okay, so in our shop, we have many products, but each and every product having the maybe the same name. So we can distinguish by the unique ID. So definitely we have this point. And now we have a many we have some faculties whose name are matching to each other, and definitely it could be happen many times. So we can provide the employee ID. So employee code of any employee becomes the key attribute. So this is our employee ID. So I'm writing our employee number. So this is what actually this is the key attributes. Now this would be the key attribute. So this can be identified by our key attributes. Key attributes. This is identified by the key attributes. That is the basic thing you have to understand. So key defines the uniqueness in the record, we can say. And we have the various kind of the keys. I will tell you later on, but I'm just discussing over here because in the next slide we have this term. So we have a various flavor of the key. One is a primary key. Primary key. I'm writing short key. Primary key. So in the primary key, what happened? You have to keep in mind in the primary key, null is not acceptable. It means you are defining any attribute as a primary key you are applying on the such attribute, then null will not be acceptable. It means you can't leave the any information. You have to put some data that should be uniqueness. So null will not be acceptable. That is the point. That is the important point. And duplicating of the data is not possible. Duplicacy is not possible. Next we have the FK, that is a foreign key. Foreign key is known as a reference key actually. This is known as a reference key. This is known as a reference key. This is known as a reference key because it will keep the reference of the other table's primary key, and with help of the foreign key we can make the relationship between the first table to the another table. So this is the example I can take over here. See this example. Student number we have, student name we have, and student course in which she or he was registered. So this is the three attributes I am taking only. Right now I'm not talking about the records only, I'm just talking about the attributes part. Next table we have, that is a faculty. So faculty number we have, or ID we can say, faculty name, and check the student number who is registered inside the faculty. So we can check this one. And student, not student, this is a course we can write over here in which she was registered. So this would be as a primary key. This would be as a primary key because this cannot be duplicacy in the record. Same in the faculty number will be the primary key. But student number, faculty can be the student. This student number can be a part of this faculty, and this student can also be a part of the other faculties associated with the course as well. So here, in this case, what we are having, we are putting the reference of the this value over here. That is point. It means in the faculty we can put the detail of the student, only those students who are really exist in the student tables only. We can't take the any data which is not associated with our student table. So suppose student name is Ram, and he is not studying in the university, or he has not opted such course only. So how the faculty and student will be mapped? So that is the point. Referencing should be proper like this one. And here the duplicacy will be acceptable because this faculty is different, but the student could be multiple times the same name we can have, because he has opted, he is under the faculty and followed by the courses only. So in this case, the foreign key, the duplicacy may acceptable. That is the point. Duplicacy may acceptable. Duplicacy is may acceptable. Duplicacy is acceptable. That is the point. And other than these two keys, we have the super key, we have a candidate key, and we have the other kind of the key. I will tell you later on, but these are the two important keys which are coming from the basics of the key. So this is the study of the key. Is clear to all right now? What is the key and what is the key attribute? Is it clear to all?
Yes, sir.
Yes. After understanding this point, we can understand this concept. So in this case, we have the two tables. One is a customer table and account table. So as I am speaking over here in the relational model, if the name is given over the data model, so data model is the data and its relationship. So how I can say the relationship can be possible? So in our relational model, that is a way by which we can say. So as you can see, the customer name Preeti, and Rocky. So Preeti is coming 3 times, so the customer name cannot be duplicated. And respectively, we have the security number, so we have the same security number, so definitely we can have the different security numbers. We can also have, so duplicacy can exist over here, so this cannot be a primary key. Address can be duplicacy, of course. A customer can have the same number of the city, same number of the address. It is also possible. The city and address cannot be, at any cost, cannot be primary key. That is a point. In the account number can be a primary key, but you have over here the 8111 is the account number that is coming 2 times. So this cannot be a primary key, but this can be a key. This can be a key. By default, we are writing anything in our table that is a part of the some kind of the key. I will tell you later on what is the key and the candidate key and super key, but here I am talking about the primary key and foreign key. So in the account number, you can observe over here in the account number A101, A125, A456, A987, and A211. So this is what? This is our key attribute, and that can be identified by as a primary key. Why? Because it does not contain any record in the duplicacy manner. Balance could be duplicacy, doesn't mean. That is the point. So from the account table, the customer will keep the reference of the account number from the account table. I'm speaking once again, listen carefully. From the account table, account number will be the reference to the customer table's account number, and here the account number in the customer table will be the foreign key. That is the point. Okay, and foreign key and primary key you are talking about. So primary key doesn't mean, but foreign key, if you are looking for the column, which should be the same. Okay, so here we have the account number, and here you have the also account numbers. It means the relationship can be possible while seeing the same account number. So if you do not have any common attribute, so how you can make the relationship? So relationship can be possible or exist when we have the common attribute. Definitely we have to keep in mind this point. So customer Preeti and Rocky share the same account number, that is 8111. That is only the meaning over here. So they are sharing the same account number because their details are exist in the account table. That is only point. So now this diagram is clear. Without the understanding the primary key and foreign key, you are not able to understand the such part. So now tell me right now, is it clear to all right now?
Yes, sir.
Yes, sir.
Yeah, good. So relationship is possible when we have the common attributes. And now we have seen the just introductory part about the foreign key and primary key. So that's good. So here we have some important points. So I didn't remove anything, but I'm just keep it as it is for your betterment, so the student can take the advantages. So the main highlights of this model, what is the merit actually? What is the advantages of the our model? Data is stored in the table that is called the relations, and it is also known as the table. Okay, so do not get any confusion. Data stored in the table is also known as the relation, as we have seen in our diagram, and this is also known as the final and general term. Relations can be normalized. That is an important term. Normalized, what we can say, relation can be normalized means, or the table can be normalized means our table can be simplified by the various mechanisms. What are those mechanisms? 1NF, 2NF, 3NF, BCNF, 4NF, and 5th NF and PCNF. So these are the various normal forms by which we can simplify our relation to remove the duplicacy, and you will see entire thing with our examples. Do not worry about this point. So that is the point we have to understand. So what is the advantage of this point? We have to understand. Relations can be normalized and data is stored in our table called the relation, and normalized means simplification. So in the normalized relations, values saved are the atomic value. So whatever value we are putting, where values means data values, and that value should be preserved. It means suppose we are having the null values, so there will be no sense, or such record will not be meaningful. So that is the point you have to understand. Atomic means we are talking about the preserve. So we can say in the normalized way, our information should be atomic, means our information should not be removed. It is just like simple example. If I'm solving any problem, and while solving my problem, my actual values will be dissolved and there will be no source. So normalization means if I'm simplifying my problem, or I'm just solving my problem with the help of the any concept, then my data values should not be changed. It is like just example. Suppose I'm talking about the simple record. So while normalization, Neha should not be changed to the any other student name. Neha will be Neha only. The word I'm putting NEHA in my student name, that will be as it is. So record should not be deleted, and record the details should not be violated. So that's why we have this point. And each row in a relation contain the unique value. So with the help of the primary key, we can handle this point. So as we have seen few seconds ago, and each column in a relation contain value from the same domain. That is a point. Same domain means we're talking about the data type. Just like example age. So I put in the age ABC. How it is possible? Any age student age can be ABC? No. It means the age is in a value, the age in a column or attribute that can handle or that can manage by the only integer type of the value. That's why we have this point. Domain means the set of the values. No problem. I will tell you each and everything properly. So I'm speaking over here. Domain means the set of the values which are associated with the column, which is associated with the only column. Okay. So this is clear to all right now. Is it clear to all right now?
Yes, sir.
Or any doubt? In these 5 points, these are the 5 advantages point you have to keep in mind. In the examination, I can ask any problem, any question from this point, so people are required to understand things properly. Let us take another example. What is this example? This is our example. Okay, I can take over here. The most common model is relational model. So we have discussed the many things properly. So without wasting much time or reading the unnecessary theory, I'm just like to go through this example only. Is it visible to all right now?
Yes, sir.
So this is the example where we have 3 different relations. Okay, one relation is we have belong to the students, which contain the student ID, first name, and last name. So student ID definitely will be the primary key, because student ID cannot be duplicacy. So it contains all the records, all the data in the uniqueness. Next, we have another table that is the provider details. So where we have the provider ID and provider name only. So provider ID will be the foreign key, and it cannot be a duplicacy. So definitely we have this point. So now in the provider ID and in the provider and student table, we have our two tables. From these two tables, we are creating a new table that would keep the reference of the student ID and provider ID. So if I'm putting the student ID in the new table, that will contain the student ID. So student ID can be duplicacy over here. It is also possible. Why? Because it is supported by the foreign key. So I'm putting over here, and provider ID I can writing over here. Here I am not repeating any record, so definitely no issue will be there. But if I'm putting, so what I'm doing, if I'm putting the duplicacy, so I need to check where the uniqueness is exist or not. But here I'm not putting any duplicacy information, so I'm putting the uniqueness way. So student ID, if I'm putting in a new table from the our actual table, that's why we have the X table. Okay, you can just see over here. This is our X table. This table is belong to the X table, and this is our Y table. This is our Y table providers. So you can observe over here if what you are observing. So provider ID and student ID becomes the foreign key of the respective column. So definitely this is also known as a foreign key. And other part, that is the column, other attributes, type of the plan, start date are the other attributes. And if we are creating the new table by taking the reference of the our two tables, one is student and provider. So this is our Z table. Definitely we have Z table. So this is the point. You can easily say there is a relationship between the student table and provider table, and we can show the relationship by the third table, that is a Z table. So from the Z table we can easily see the relationship, and this relationship can be happen by the various types. So what are those types? One-to-one relationship, one-to-one relationship. This is the point. A student can take the admission in one course only. So the course, okay, so degree. So degree and degree course and a student, there will be one-to-one relationship and one-to-many. A student can opt the many courses. So this is what, not degree. I'm talking about subject. A student can opt the many subjects. So this is what, this is a mapping between the subject and student details. We have the one-to-many and many-to-many. Many faculty can teach the many students. So this is a one-to-one relation, man-to-many relationship. As a faculty, I can teach the many students. So this is a one-to-many. Okay, and man-to-many means and many faculties can teach the many students. So this is known as a man-to-many relationship. Okay, so this diagram is clear, or any doubt you have? Whatever we have discussed, this is summarized part. Just tell me right now, any doubt?
No, sir.
Okay. Okay, so the table we got over here by the join operation. So I will tell you join operation later on, but here no need to discuss the join operation, but you have to understand these two tables are joining, these two tables are merging by the sum operation, that is known as the join operation. So join operation we will see inside our practical part as well as theoretical part. Now advantages. So what is the advantages of our this point? So the main advantage of this model is its ability to represent data in that simplified format, that is a tabular format. And the process of the manipulating record is simplified with the use of the certain key attributes used to retrieve the data. And third point is representation of the different types of the relationship is possible with this model. So in this relationship model, we're talking about the one-to-one, one-to-one, one-to-many, many-to-one, and many-to-many. Practically, actually, theoretically, we have the four types of relationship. One is a one-to-one, one-to-many, many-to-one, and many-to-many. But one-to-one or one-to-many, one-to-many or many-to-one, there is no difference. Why? Because if you're reading any information from one direction, then you are speaking one-to-many, and from the opposite direction, it can read by the many-to-one. So there will be no difference between the one-to-many and many-to-one. That is the point you have to understand. So this was the example I have taken. Now, After understanding our model, that was we have discussed, that is known as the relational model. So after understanding relational model, next we have the network model. Most of the time we will talk about only the ER model only and about relational model. But network model and hierarchical model we will never like to use, and because it is not complex, but for implementation it is not easy to. So that's why for implementation it is very complex, we can say, but for understanding purpose, for theoretical it is very simple. But for implementing purpose, if we have a complex in this model, so that's why we will not implement the network model and hierarchical model. So let us understand the thing properly over here. So the data in the network model are represented by the collection of the records and the relationship. So the data in the network model are represented by the collection of the records and a relationship. So among data are represented by the links which can be viewed as a pointer. So if you remember any idea about the linked list, what we have done from the linked list, you have observed one node will keep the address of the next node. So there is what? The one node will keep the address of the next node, means there is some chain or the linking between the one node to the another node or next node. So first node will keep the address of the next node, and this is the chain we have. So that's why we have the linked list. So from the linked list advantages, or from the about this point, we have to study this point. So if you remember the customer table where we have seen the Priti record, the Priti is the customer name and whose social security numbers and his address and city. So this will be mapped by the two parts. One is a A1001 and 1000 and A456 and 5000 and A111 and 3000. So from the account, so you can easily say, just let us move to this point. This is our table. Yes. So from this point, Priti. So Priti will belong to the this record. I'm highlighting. So please check highlighted points. So this record will be mapped with this point. You have to understand. So you can easily check the Priti is the customer who can be connected with the other table by the account numbers. So that is why we are making a network. And now what you are observing, you can easily say observe over here, Priti and Rocky are the two customers who are associated with the same account number. So from this example, we can say if we want to make the network, then we can easily make the network by making the chain. So the point you can observe over here I'm not at the last, I'm just marking by the different. At this point I'm not marking, just look at the right side where I'm just marking the dark circle. Here we are not writing the account number. So what happened, this is a record which belong to the Priti, the record which belong to the Priti, and she belong to the account number 8111. Okay, so then what happened, this record will be connected by the account number relation, account number table, and this will map to the this record only. Which record only? A111 3000, because that is associated with that part only. So the account number customer can make the relationship by the network model. That is the point you have to understand. So that diagrammatically it will be represented like this one. In the customer table, we are not writing the entire detail. We are not using the account number part, but we are keeping the we are refining that this record, that is Preeti 111 222 3456 Bangalore. This will contain the address of the account number's address. So when it is keeping the address of the account numbers, account number part, account from the account table, so it will directly jump to the respectively account numbers. That is the nature of the, or that is the advantage of the network model. So that is the point we have to understand. See, you can see, observe it. So here I'm just writing the something, I'm speaking something properly. The network model builds the hierarchical model by allowing many-to-many relationship between the linked record. So you can easily check over here, network model builds on the hierarchical model by allowing many-to-many. So if we are creating the network model, then what we are accepting, we are accepting the many-to-many relationship will be exist between our linked record. So you can observe over here, the Priti can be connected by the many accounts, but this record will be associated with the other part as well in the network model. So in the what we are observing, the customer relations, customer table and account table, we can have the many-to-many relationship because many customers can be connected with the many accounts. And it is also really happen with the practically. It is like a simple example I can speak over here. As a I'm speaking talk about the myself only. Suppose I have the 5 accounts. So as a customer, I have the 5 accounts, but my identity is not identified by my photo or my name only. My identity will be identified by the how many account I have. So suppose I have the 5 accounts, so that is the account number will be my identity. So I have the 5 account numbers, and all those 5 account numbers can be associated with the many products of the banking, just like the very different products like the FD or that is a RD account, recurrent deposit account, or you get the fixed deposit account, or any different kind of different accounts I can have. So I can map my 5 accounts to all these facilities, so I can have the many-to-many relationship. So in the network model, we can say all the accounts or all the things are connected to each other. Definitely, this is the point we have to understand. So it is just like the example we can say student or parents relationship or student faculty relationship. A faculty can have the many students, or many students can be connected to the many faculties. So relationship can be stand for the many to many. So based on the mathematically set theory, the model is constructed with a set of the related records, and each set consisted of the one owner or the parent's record and one or more member or child records. So a record can be member of a child in a multiple set, and allowing this model is convey complex relationship. Definitely, we have to understand this point. And it was a popular. The network model was popular in the 1970s, and when we formally defined by the Codacil. Codacil basically it just nothing. There was conference while during the conference on the data system and language. This was proposed, and this was popular during the 1970s. But we are living in the today's era where the ER model was more popular along with the relational data model. So network model was not popular nowadays. Now it was not popular, and now it is now much popular. Not much popular, but previously in the 1970 it was used. It was used and it was most popular because now they have used the data structure based linked list based approach. So they have connected all the records properly. So the relationship will be easily to find out. That was the reason only. See, this is our example. So in the network model, you can see observe over here a vendor. Vendor can be the type of the any relation, employee, customer, and product. So employee will be connected to the vendor, customer will be connected to the vendor, and product will also be connected to the vendor as well. So a vendor can be connected by the three different entities. One is the employee, customer, and product, and this is also known as the relations. And ultimately, what we are observing, all these are connected by the sales transaction. So simple like example, employee can connect to the vendor to giving the order, and if the order is given by the any employee, or any order is which is manipulated by the any employee of the organization, then how many customer he or she is manipulating in for the selling purpose, and what are the product he or he is sold by the marketing purpose. So total number of the ultimate goal was a sales transaction. So ultimately we have a sales transaction by which we have to do think properly. So vendor will be connected by the employee and customer and product. So these different entity or these different relations are connected to the vendors only. So what we are making the network, or this is represented by the hierarchical models. This is represented by the little bit hierarchical model, followed by the many to many way. So we have this different advantage, but hierarchical model is little bit different. That is the point you have to understand. Hierarchical model is little bit different from the network model. I'm speaking once again. In the network model, we are using the linked list based data representation to connect the one record to another record. That is only meaning. When we're talking about its advantages and the network model, advantages, we have the representation or relationship between the entities, or we're talking about the relation or table, is implemented using the pointers only, as I told you many times, because two tables are connected by the pointers only, two records are connected by the pointers only in the network model, and which allow the representation of the arbitrary relationship. And unlike the hierarchical model, we will see the hierarchical model, it is much easier than the hierarchical model, and data manipulation can be done by easily with this model only. And data manipulation can be done easily by this model, of course. Just like example, I have mentioned over here, Aadhaar card. Aadhaar card, why Aadhaar card? So Aadhaar card will keep the detail of your biometric detail. Aadhaar card details will be maintained by your biometric detail only, and it is also represented by the different database. And now you are connecting this database to the bank or any other organization to security purpose. Then what happened? Bank is connected with the any other database. So now these two database will be connected by the some way. So our bank is not connected to the one other card. A bank can connect it by the many other cards of all the employees. So many customers will be connected by the one other card and many other cards respectively, we can say. Many to many, one to many is also possible in the our banking application. So hierarchical model is coming from this point. So whenever you are updating something, I'm speaking real application. Whenever you are updating something in the other card, suppose you are changing the address, you're updating the contact details of the other card in the other card. What happened? Then you will go to the visit the bank. Okay, you will go to the bank and visit the bank. You ask, I need to withdraw the money, so you need to fill the KYC form again. What happened? Just because you have updated some details in the Aadhaar card. So in the Aadhaar card, what you are observing, that changing in the one database, your other database will be reflected because it will keep the address of the next address. So that's why we are changing something in the Aadhaar card. So again, we have to do the same process, fill the KYC form and fill the proper details, and your detail will be rectified soon. Now you can go next time, then your problem will be sorted out within the couple of the minutes only. So this is the example which is coming to the network models only. So that's why I put it over here. Next we have the hierarchical model. Hierarchical model is not a tough model. This model is inspired by the tree data structure. I'm speaking once again. The linked list data structure will be implemented into our network model, and hierarchical model will be implemented by the tree data structure. So as a parent-child relationship, you can easily say that there will be the one root of one parent and other would be the child or children. So definitely we have hierarchical model. Hierarchical model organizes the data into tree-like structures, as I told you, where each record has a single parent and a root, and sibling records are sorted in the particular order, and this order is used as a physical order for storing the database, and this model is good for the describing many real-world applications or relationships. Let us understand this point right now. Is it visible to all right now? Is it visible? This diagram is visible?
Yes, sir.
Yes, sir.
Okay, in this diagram, what I'm using, I'm taking the simple diagram which describes the hierarchical. So grid apps is the one entity. So grid app is divided into its different children. So what are those? Orangutan, gorilla, and chimpanzee and human. So we have orangutans, gorilla, and chimpanzee, human. These are the four different category of four different sub, or we can say children of the grid apps category. So what I'm observing, I'm just making the categorization, or we are representing data in form of the hierarchical way. Now, orangutans also having the own children category, or we can say category, that is a Bornean orangutan and Sumatran orangutan. So now we have the gorilla. So gorilla is divided into the two parts. One is eastern gorilla and western gorilla. Chimpanzee also divided into two parts: common chimpanzee and bonobo. And human is also divided into the next part, that is the modern human. So now you are observing whenever I need to create the or access the data that belong to the bonobo. So what happened? With help of the hierarchical model, I can easily identify in which root I belong to. So that is a bonobo. Bonobo means I belong to the chimpanzee. So definitely this is the point by which I can easily find out the my information, or I can easily find out the my data from the hierarchical model. So hierarchical model for seeing it is very simple, but it is not easy to implement compared to the network model. Network model is easy to implement because we have the data structure linked list. But tree data structure is not easy to implement because we have to do more hard work to implement this model. It seems to be very simple, just like the parent-child relationship we have, but it is not easy to implement. That's definitely we have to understand this point properly. Suppose I'm talking about the Western gorilla. So Western gorilla belong to the gorilla parent, and gorilla belong to the its parent is great ape. So we have this sequence we have to follow properly. So Western gorilla or Eastern gorilla is not a part of the orangutan. So we have to classify the data, we have to categorize the data by the hierarchical model properly. So, but it seems very easy, just like it seems as a tree data structure. And this model was primarily used by the IBM information management system in the 1960s and 70s, but they are rarely seen today due to the certain operation inefficiency. That is the reason only we will not use the hierarchical model in today's era. And definitely, unlike the hierarchical model, we will not like to use the network model. So most of the people will like to work on the ER model, and we have the relational model. This is the point we have to keep in mind. But for theoretical purpose, for notes purpose, for the understanding purpose, we have to identify there are the 4 types of the models we have to understand. So what is the advantage of the hierarchical model? Simple. The representation of the record is done using the order tree. Definitely order tree we have. And which is the natural method of implementing of the one-to-many relationship. And proper ordering of the one-to-many means many children can have the one parent. Many parents cannot have the one child. That will be the meaningful we have to identify. So that's why it is useful when we have the one-to-many relationship. The proper ordering of the tree result in an easier and faster retrieval of the records because we can directly jump on the particular part only. So along the use of the virtual record, the result is stable database, especially when modification of the database is made. So it seems to us we can easily find out, and this is applicable when we discuss about the object-oriented database management system, and that is known as the OODBMS, or sometimes it is known as the DBM. So object-oriented database we have to study. So at that time, this will be much applicable. But it seems too easy to implement, but it is not easy to implement. It takes much time. And virtual tree would be the great example when we have to store the information in the tree manner. So hierarchical model has been changed into the B plus tree. We will see that part, that is the file organization. So inside the file organization, we will see what is the B plus tree and how to store the information in the tree manner. But that would be represented by the sorted order. That part we will see later on. But here we are talking about the what is a hierarchical model and how hierarchical model will work and how this is going. So I'm speaking once again, network model and hierarchical model is not much usable nowadays. We have the ER model for the graphical representation that we will use, and for implementation purpose we will use the relational model. That is the point. So now we have the ER model. So before moving to the ER model, just can anyone tell me right now any problem you have? So please you can ask me right now. Yes, tell me any problem so far? Okay. So this is a PPT. We have the 4th model. We have a entity relationship model. This model is shortened by the ER model, that is entity relationship model, and this is really work on the real world problem or real world entities, just like the student faculty, a room and the class, the room and students we can communicate. So while formulating the real world scenario into the database model, ER model creates the entity set. No problem, I will tell you each and everything properly. Whenever you have any problem, you can ask me. And next we have the relationship set. And next we have the general attributes and constraint. So general attributes means we're talking about the columns, and constraint means we're talking about the foreign key, primary key. An entity set means the list collection of the all the entities. What are the real world entities could be? In a room, we can have the chair, we can have the table. Okay, so we can have the real world entities, that is a wall, number of the walls. We can have the lights, okay, switch. All these are the real world entities. What is the connections? What is the relationship between the wall and switch? So we can have, and a relationship we can easily identify. One to one, one to many. A wall can have the many switches. Suppose that I'm taking simple example. A wall can have the many switches. So what is one to many relationship? Okay, that is important point. And ER model is best used for the conceptual design of the database. Here we have to understand. So it contains the two parts. What are those parts? As you can see, entities and their attributes. So what is entities? Entities means I'm talking about the name of the or the table or the relation or the file. So very practically, you can say, or the diagrammatic or depictive nature, we can say entity means I'm talking about the table name. A table can have the many attributes, or the attributes means we can have the column. So relationship between those entities. So a customer and account. What is the relationship between the customer account? If these are the two entities, if these are identified by the two tables, so what is the relationship between these two tables? And that is identified by the its type, that is one to one, one to many, many to one. From this point, we have to start the ER model. So let me know right now once again, any doubts so far? If you have, please you can ask. Any doubts so far? Yes, tell me. Any doubt so far? Okay, now tell me, any doubt in the relational model, network model, and hierarchical model? In these three models, you have any doubt? Yes, tell me right now. Any problem?
No, sir.
Okay. So ER model, I'm speaking once again, ER model is a conceptual design of the database or model. We can say it is the most important model after the relational model, and that is used to depict the information in two ways. One is the entities and their attributes, and what is the relationship between the entities. So these are the two points we have to understand. Let us understand the simple example. Entities. What is entities? Entities in an ER model is a real world entities and having its properties, and those are known as the attributes. So if I'm talking about entity student, so student entities can be identified by the student name, student roll number, student class number, student other details as well. So can anyone tell me right now what would be the entity, what would be the attributes of the table entity? Table entity, what would be the table entities? Just could you only tell me right now what would be the attributes of a table entity?
So color,
Okay, super. The color,
type of wood,
type of the board. You can take the type of the material, because the table can be the plastic type. Table could be steel table. We can have table could be the wooden table. So we can say material type. Okay, good. Next one.
shape,
Okay, shape. Okay, good. And other one. We can have the weight of the table. Suppose we have the very big table, so it is a we can say that it has the own weight. So weight could be the one attribute. So weight, size, shape, color, and material. So all these are the properties of the our table entity. So table is a real world entity, so we can have its attribute, and those are known as the properties, or those are also known as the attributes. Same thing, relationship. So table, how a table can be read with the chair, of course. Unlike the table, our chair can have own properties, own attributes. So our table will be associated with the 4 chairs. Of course, it is also possible. So in a conference room, suppose in a conference room there is a round table. Yeah, definitely shape we are talking about the. We are not talking about the square table. We are talking about the round table. It is also possible. Square table we can have, rectangle table we can have. Okay, so there are many variety we can have. So in a conference room, we have a round table. So inside the round table, so approximately 10 to 12 chairs are associated with the table. So there is a relationship between the table and chair. Definitely we have to connect our problem, our concept with the real world things. Then we will understand the concept in a simple way. Definitely we have this point. So relationship is nothing which describe the connection between the uh, current entity to the next entity or the other entities. Definitely. So relationship between the student and faculty we can have. The relationship between the student course we have. So as a course, what is the relationship between the connections between the or relationship between the student faculty based on the course. So I'm offering the course DBMS 3 CSE 3001. So you are opting this course under me. So definitely what we are connecting. I was not aware you previously. I was not taught you previously, and you don't know about me, where about myself previously. But this time now we are connected. Now we have the relationship. So what we are based on the course. The course is database within the system. So this is what this is known as the our courses. So this relationship can be one-to-one, one-to-many. I'm not teaching the one students. I'm teaching the many students. So there is a relationship between the one-to-many. So as a faculty, I'm teaching to many students into the my class. So this is known as the one-to-many relationship. Okay, and many students are taught by me. So from the other direction, I'm reading the statement. Many students are taught by me. So this is known as the many-to-one relationship, but we have the same sense that this is a point. So relationship can be identified by the mapping cardinality. So I'm just highlighting this point. So please keep in mind, a relationship can be identified by the mapping cardinalities. Mapping cardinality. In the examination, this question can be asked by the this way. So you people are not required to be confused. So mapping cardinality could be the one-to-one, one-to-many, many-to-one, and many-to-many. So if talking about the one-to-many or many-to-one, we have the same sense depending on the reading from which direction I'm reading the statement. Now, the introductory part about the ER diagram is clear. Yes, tell me right now. And in this case, you have to do some practice during the exam class time. So just focus on this problem right now. Is it clear to all the introductory part? The ER diagram is clear. Introductory part is clear to all.
Yes, sir.
Okay. So here I'm just explaining my idea with help of my written material or design way. So entity or real world object we can say. So relationship basically between the our entities could be. So suppose we have n entity E1 to E2 and so on and so we have the En entities. So these entities can make the relationship. So a relationship will be exist between the only entities only. So student entity it becomes our first entity that is E1. Okay, so student become the our first entity, that is I'm just showing only the E1 only. Student contain its attributes, so I'm writing the student ID, student name, and student age and course ID. But you people have to ask me the question, sir, why you are putting the student in the square and other attributes are represented by the circle or eclipse? Yes, my dear, there are some notation. So that part we will see in the next class deeply. What are the notations of the ER model and how to draw the ER model? But before that, let me explain this concept properly so the thing will be clear to all the people. So ER model is the fourth model data model which is used to depict our problem through the entity and attributes, and it is followed by the relationship. So student and faculties belong to the relationship, that is the name I have given over here, the relation model, that is we have the R. So R be a relation between these two entities E1 and E2. Okay, for understanding purpose I am speaking only here. So what are the two entities? Student faculties only. So student ID becomes a primary key. So I have written over the PK. So faculty is also having the some students details. So that is identified by the student ID. So we have this student ID I have over here, and that is known as the foreign key. So while offering the course CS 3000 to 1 as a database management system to the student, those who belong to 20 MI or 20 VI something. So they will be the my record here. Next time, suppose I am teaching the applied machine learning. Suppose I got a chance to teach you the applied machine learning. So subject name will be changed. Faculty name or faculty ID will not be changed. But student ID also be same we have. So what we have 20 BI something student is coming inside the next time to the my course. So in terms of my database, what I'm observing, I'm also having the student ID same ID. So duplicacy can exist. So this is the point we have to understand. So faculty name and faculty ID we have over here, and the course ID we can connect over here. So course ID and course ID followed by the course ID we can make the relationship. So course ID is what? Course ID is a common attribute by which we can make the relationship between these two entities. So I can write over here just for your sake of the knowledge. This would be the common attributes. This is the what? This is a common attribute. Without the common attribute, you can't make the relationship. And my dear, don't worry, I will show the practical part, all these things. So the things, the picture, the idea will be clear to all. So for doing the better learning, you people are required to do more practice at your end, then you can learn the thing properly. This should be the common attribute. So here we have a common attribute, that is the course ID. Okay. So what is the relationship between the student and faculty based on the course ID? So this as student ID I'm keeping as a record. So this would be the foreign key, while this student ID becomes the primary key. So student ID, student name, student age, course ID was the attributes, and faculty ID, faculty name, faculty, student course ID, student ID are becomes also the attribute of the faculty entity. So this is just idea I'm showing over here. So these are the some notation, and I will show the entire notation. What are the very notations we have? For example, the things will be clear to all. Okay. So tell me right now, any problem so far, or anything you need to ask?
So in ER models, over here we have a common attribute course ID. So in every ER model, we'll have a foreign key to establish a relationship between the tables.
It is not required, but we need this foreign. So without the foreign key, without applying the foreign key constraint, you must have this common attribute. See, foreign key means I mean to say speak over here. Foreign key will keep the reference of the other entity. So what is the thing by which we can make the relationship? So we can say in ER model, we must have a common attribute by which we can make the relationship. That is the first point. Foreign key and primary key are the key constraint which describe that you can make the relationship between the two entities. So foreign key play important role. So with the help of the foreign key, we can make the relationship between the two entities. So that's why we have done foreign key or primary key are the implemented part in our database. But while we have to use the common attribute, just like speaking term or key attributes by which we can say. So common attribute we can say we have to use to make the relationship. Okay, suppose you don't have the common attribute, so which attribute or by which we can make the relationship? Can you tell me right now? Suppose we don't have any common thing between you and I, so how we can make the relationship? Just can anyone tell me right now? What is the point on which I can make the relationship? Now, can you tell me right now? So at least one thing should be common between you and me. That is course by which we are connected. So one thing should be common.
Okay. So there should be a common attribute, but so if we are using foreign key to link these two tables, even if both tables have a common attribute and we haven't used a foreign key to link them, then how are we going to establish a relationship between them if there is no link in between?
See, that is a good question asking me right now. See, what happened in the student table, student relation, if I'm inserting the student ID. So if I'm taking the reference of the foreign key, as a practically we have to use the reference key concept. Practically, before implementing the practically, I will tell you how to design the ER model and what is the way by which we can communicate. And for the implementing purpose, I will tell you how to define the reference. So how it is possible, and that is possible by the references purpose. So while implementing, while designing the faculty entities, I will add one more entity, that is student ID. So I will keep the reference of the student ID from the student relation. So I must be known to, as a faculty, while defining the student entity or student relation, I must be known to this point. There is a and attribute that is named as the student ID. So I'm just keeping inside the my table. So that will keep the reference of the student. Without knowing this, how I can make the relationship? That is the point. So we have to know. So faculty must be known to this point. There is a students which are student ID. There should be exist and that is available, so we can make the relation. Suppose I'm not putting the student ID. I'm not putting the student ID and a course ID, and I'm just putting the faculty ID and faculty name. So how we can make the relation? Now can you tell me right now? How we can make the relation? So at least one common attribute is required.
Yes, sir.
Okay. Next, I'm showing the next diagram. So I think the picture will be clear to all right now. See. So a student asked me the question. So I have depicted my example over here. See, in the room is I'm giving the E1. E1 is just for understanding purpose. In the while designing the ER diagram, you are not required to write the E1 or E2 or R. For understanding purpose, I'm just writing the E1. So for E1 is our entity. So room is our entity. So I am giving the room number. So in the my university, we have the various room number. So A block, B block, so room number, each and every floor we have. So that is belong to the unique room number. And we have the some other details of the over here. So at the time of the examination, I have given the exam ID. So exam will contained by the exam ID. So exam ID, I'm giving the EID. That is a exam ID. So the invigilator I'm assigning as a COE, I'm assigning the invigilator. You have to go in such a room. So that is your ID. So that is not an exam ID. So in a day, exam ID will be the unique to define the you have to go in such a room. That is the point in the morning shift. Next shift, what happened? Exam ID, I can use the same exam ID to the another room, or we can say the new same inhibitor go into the another room. So definitely in the room we can say the multiple times I can come. So may there be some chance in the morning shift or in the evening shift I can come. So duplicacy will be there. So in the exam ID would be the our foreign key. So what you are observing, exam ID would be our common attribute by which I can make the relationship between the exam and a room. This is only the for knowledge purpose. This is for idea purpose. I'm just giving the my idea over here. On which date I have, on which subject I have to take the exam. So all the things I mentioned in the exam part, date and a subject and exam ID only. And in the room, I'm just taking the exam ID, date, and other part and room number and other details. So this is the point we have to understand what you're observing. You can make the relationship between the one attribute or common attribute. See, read this statement. I didn't read, but I'm speaking over here. The logical association among entities is called the relationship. Relationships are the mapped with the entity in various ways. Mapping cardinality defines the number of the association between two entities. So what is mapping cardinality means? How you can map your information to the others. So at least one common thing on one thing is required by which you can connect. So without connecting such thing, how you can say you are making the relationship. It is just only the normal thing by which we can understand. So how a table and a chair can be communicate? So by the room, because these four chairs are available in these rooms, and this table is also available in this room. So we can say the room is the common attribute. Room number is the common attribute by which they can chair and table can the communication or can make the relationship. That is only the point. So something in the ER model, what happened? This is known as the conceptual designing of the database model. Why conceptual? You have to use some concept, you have to use the logic to design the structure. That is the point. So that is the important point we have to understand. So now clear?
So, in the previous example, the exam and room, yeah, yes, sir, this one. So, even in this, a foreign key, you have introduced a foreign key to establish a relationship. Now, the computer won't be reading that relationship if a foreign key is not given. It requires certain commands to recognize it as um, a link. So even though common attributes exist between two tables, still we will have to introduce a foreign key to help the computer understand that a link has been established.
No, 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 no. If you are defining the common attribute between the two table or two entities, then you have to define expertly this is the reference we are taking from the such table, because in a database we can have the thousands of the entities or thousands of tables. So how two tables can communicate? So we have to expertly define we are taking the reference or we are defining such foreign key from the such tables reference as a primary as a foreign key. So without defining this thing, you can't justify this point. You have to explicitly define as a reference we are taking. I will show the proof of this thing with the practical part. Because in a database, I will have the 10 database or 20 database only in the semester. But in the real world, we can have the 1,000 database. So how I can say which table is connected to which tables? So how these two tables are communicate to each other? So we have to define the explicitly we have to define the relationship, and we have to define the references. Without defining the references, you are not able to say you are making the relationship between the two different entities. There are many attributes, there are many entities, they can have the common attributes, but without defining explicitly how we can say the relationship exists. This is a common thing.
Yes, sir.
Okay, so we have to define, is it true? Without defining explicitly how we can say. See, simple, look this example. In this university, every time you are coming to the mic even and say good morning, good afternoon, every time I know you, but there is no relationship between you and me, because I'm not teaching you any courses, but just and only just you have seen my profile over the internet and just telling me, sir, okay, good morning, good afternoon. Sometimes you're meeting me while walking in the corridor, you're talking me anytime, but there is no proper relationship between you, no. In database based on the database, there is no relationship between you and me, because I'm not teaching you or you are not part of my any courses. So at least one common thing is required, that is course by which we can communicate. So I will define expertly. So in the practically, we have to define such thing expertly. We are taking the reference or reference of the such table as a primary key, as a foreign key. So definitely we are making the relationship. Definitely it is true. Without defining expertly, you can't say this thing. Okay. So now clear?
Yes, sir.
Okay, so no problem. After understanding the ER model properly, I will tell the everything with the practical. So just like yesterday, I told you about the DDL and DML. Okay, so everything will be practical, so the thing will be clear. Okay, okay, students. So tell me right now, any problems so far you have?